let me rephrase that. G'day and welcome. Welcome back. I am very happy to have you here for episode 6 of Whether or Not. I love a sunburnt country, a land of sweeping plains where crocodiles and great white sharks love to chomp your brains. Yep, I am StellaQ and, well, I'm going to put the Billy on for this one. Not that Billy, no. Not the viral-loving, money-grabbing, philanthropogenicist, window-peeping, pie-faced Billy. No, the Billy where you camp by a billabong under the shade of a coolabah tree and you wait for it to boil as you watch the jumbucks being jolly. I'll swing one for you. If you haven't put 2 and 2 together by now, let me spell it out for you. Aussie, 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 oi, oi, oi. Yes, we are wandering into the great southern land terra firmament, so watch your step. She's as beautiful as she is cruel. And the big skies are pretty big, with a capital BS. Speaking of capitals, this is a land of deadly creatures that are out to get you at every turn. Most of them can be found thriving in slimy dark corners in Canberra, while some dwell underground, where their skin would shrivel if light were ever to find its way in. And then there's the wildlife. And unlike our politicians, we have no immunity to damage from big storms, but we're a pretty tough bunch, so we're generally ready to face what gets thrown our way, natural or synthetic. And as technologies and progress seem to be presenting more and more questionable materials for us to digest in our daily feed troughs, the truth can get a little blurry and a little lost in all that fuzzy wuzziness. But fortunately, we know a guy, right? Jeff is a man on a mission, and he's got the cool sunglasses to prove it. And as he peers into the bright abyss, he can read the signs and translate the cloud codes into something more doable for some of the rest of us who suffer vertigo from walking the tightrope of the mainstream weather wubbish. So here we go, on board for our second Whether or Not Q&A, or Wonka Wonka, in pursuit of the plain truth as we dive deep into the big question. Was it weather or not?
Within whose walls hearts were nourished, from whose gates they went forth in power.
Here's the story. We had a very long dry spell from around about early July up until about the same time in August. Okay, so first of all, let me set it up. We're talking on the east coast here of New South Wales specifically. I'm up in the northern areas. My friend is about 2-3 hours south of me. So, yeah, we had a very long dry spell, early July to early August, and then we got dumped on. So basically overnight, we got around about 100 millimetres after almost a month of barely anything. And my friend a little bit further south of me reported that she'd seen a couple of planes with lines behind them. And she was very suspicious of them, and she said that she could see the lines going right up the coast as far as she could see. So I said that we would tackle this and see if we could find some cloud seeders, or whether it was it weather or not? TM question mark. So Jeff, over to you.
Okay, so orientation-wise, right here, this was on the 7th at 00 Zulu GMT UTC. So you could see there was if you are a weather person, I don't want webcams. This right here is a cold front. In the southern hemisphere, things travel in a different way than they do up north. They come from the southwest and they move towards the east, toward the northeast. So this is a cold front right here. That's a low pressure center. Things spin backwards. They spin backwards here compared to their northern hemisphere is different. Yeah. So right here, the spin around that low right there, that's a low pressure center, is clockwise.
Yep.
Clockwise right here for this trough of low pressure. Every trough of low pressure, and this is a trough again, and this is a low because there's the actual circulation center right here. That's where your weather's located. When you have high pressure, you don't have that. You got another low out here. These are all the fronts that are associated with those lows. So just in the past day or two, on the 4th, I think that one passed through. Let me back up a little bit right there. You could see it's
this is the 4th of August. Okay.
4th of August, right? So you could see it right here. I'm just going to step through. It's going through Sydney right there, and then it's going through Brisbane right about here, and now it's offshore, and it's forming a new low pressure center as it gets to the warm water. So that steps through in time, and we can look at the satellite information as well right here. So look at the satellite. That's actual radar. So here's the satellite that goes with that, and it's becoming nighttime right there. It's daytime over to the left, and 2000 hours is when you normally have on the West Coast. This is, let's see, 0600 UTC. Have you ever converted that, Stella? I had that figured out.
It
light.
Was 10 hours difference between UTC and our time, AEST.
Okay. So anyway, you see the dark coming in right here, and if I go forward, you could see it gets dark here, and it's 0900 on the 6th at that point. So this is before the storms happened. There were two cloud seeding, or two periods of time that were brought up in the person's questions. And one was on the 7th, which is right now, right here, where I'm showing this. And then again on the weekend of the 12th, 13th. Does that sound right, Stella, until last Monday?
Yeah, 10th, 11th, 12th. It was overnight on the 11th that we got the big dump.
Okay. So you had two periods, and we're going to look at both of those. So
yeah, that calendar that we're seeing there, that's based on UTC time, isn't it?
Down here, this is Pacific. It goes to my computer time, what it's set for. That's where you're seeing Pacific time. Yes,
yep,
the calendar and this time are Pacific, but up there, up top, right there is UTC.
Okay. I guess what I'm asking is sometimes because we're 10 hours difference, you might be looking at August the 6th, but in reality, it was actually August the 7th because it's the 10-hour difference. So if it's before midnight, you'd be on a different day. That's a very confusing way of putting it, but I'm trying to determine that calendar. Are we looking at AEST or UTC?
You're looking at Pacific Standard Time because it's my computer that it's on. If you were looking at this, it would be showing Australian time on your computer. So
right.
That's why we have to use UTC. You have to look at that number above that matters.
Yep. Okay. Standardizes
everything. So anyway, you could see from watching this now on the 7th, I'm going to go to radar. So this is the first period where there was a little bit of rain, and I look for cloud seeders. So I'm going to zoom in right here a little bit, quite a bit. And you can see there's very little rain coming on shore. So
yes, okay, let me just say, this is the day, the 7th, I believe it was, the Wednesday, yes. That's the day that apparently there was some cloud seeder planes spotted. So that was part of the question.
Let me jump to what they probably saw first. I'm going to jump out and take care of this part before looking for the cloud seeding. Cloud seeding and cirrus tracks, jet exhaust trails, chemtrails, people call them both things, and they are both. They're both water vapor, and they are the nasty unburnt parts of the fuel.
Yeah.
Right. The heavy metals that are not refined out, they end up falling out of the sky. So it's both a chemtrail and a contrail at the same time. Yep. So
yeah, can we get that straight, people? It's both. A contrail is a chemtrail.
3 satellite views right here that are going to show you, or maybe it's just 2. This is what I'm looking for right here. There's your daytime picture. The light blues are low water clouds from the legend down below. Low water clouds is the light blue. So all these clouds that you can see up here, they're low clouds, but there's some high clouds. Thick high clouds are the yellow. Red high clouds are ice clouds, or the thin high clouds. So you got greens as well, glaciating cold. So these are the clouds, these green ones right here are cold but not frozen yet, going to ice. So
Right.
the second view shows cloud top temperatures, and -40 is where you normally see contrails. -35, -40, -45, and then as you get colder, you see a short contrail. It dissipates really quickly. So
Can I just ask, are we talking Fahrenheit now?
These are Celsius. Yeah, all
Okay, all right.
the radiuson data is Celsius, unless, I mean, on the data that you saw, it's always in Celsius. The diagrams with the two lines, that's in Celsius. Only time that goes to Fahrenheit is if I forget to switch it from Fahrenheit because I wanted to see it in Fahrenheit.
Yeah.
But
Okay.
it should be shown in Celsius all the time.
Right.
So you can see right here over Brisbane, that's a white temperature that corresponds with -40. When I go to this different view, that's called the upper level tropospheric water vapor view.
Okay.
This other view is
This is a
called
view that you can choose within the app, is that correct?
Yes, so you can change it here under this product thing. There's the drop down right here to all these views of different clouds. What I'm looking at now is called the split window difference grayscale. It's made for looking at contrails.
Okay, and what
Well,
is
I don't know
this
if it was made, if it was specifically for that, but that's what it's good for. And I'm going to zoom in and hope this doesn't go away.
What app are we looking at the moment there, Jeff?
This is called RAMMB slider.
Okay.
RAMMB. I'll give you a
Is
link
that an
to
app
this.
or? Okay, great, thanks.
And I'm looking at the satellite of GeoCompsat. And look, if you look down here, those are contrails.
Mm-hmm.
They like that -40 zone that we saw in the previous picture, right here, where it's bright white. If you look at the scale down here, -40 is right near the bright white. So if I can find bright white here on this view, I can think that there might be contrails, and this shows it perfectly. So I'm going to see if I can play this and see if it will play. And it's only a 3-hour loop, so it should show that there were contrails that day. It's loading, it's loading, it's loading.
So my friend did see what she saw, and this is the 7th of August. So this is the day that she said that she saw them. So makes sense.
And it's not related to cloud seeding. This is related to cold, moist air where the conditions were right for a jet exhaust trail. Call it a chemtrail, call it a contrail, whatever you want. They'll be visible and they're persistent in this case.
Because let's just reiterate the fact that they are always there. It's just that sometimes with certain conditions, we can see them.
Yes. And these are the conditions. And if I look at windy sounding from Brisbane here, I'm on the wrong one. Let's see. I got to click it over.
It's the same thing as like when the weather starts getting a bit cooler and we breathe out and we can see our air breathing out, or hog, or whatever you want to call it. It's the same principle.
Right.
Like we're always breathing, and there's always, well, that terrible carbon dioxide coming out of our mouths. Stop breathing, people. But yeah, same principle.
Well, so when I look at the sounding data right here, I can see that up near 30,000 or 10,000 meters, starting like right here, there's a 5-degree dew point depression right there at 10,082 meters. And if I go up to here, that's a 5-degree depression. That's an area of clouds up to between 10 and 11,000 meters. So that's 4,000 or 5,000 feet thick, where I have a zone that is appropriate for cloud formation and also appropriate for Contrail Formation.
Mm-hmm.
And that's based on this sounding here, Williamstown, which is south of Brisbane. And I have this the right time frame. Yeah. Okay, so disregard what you see in this picture right now, because that picture is the current picture. I'm looking at historical data back to the 6th. I'm looking right here at 2300 Zulu, which would be, the start of the 7th.
That was about
London
9
time.
o'clock on the 7th. Yeah.
Right.
9 o'clock a.m. Yep.
So this picture does not match up with what you're seeing in this data right here.
Okay.
And this data is telling me there's a lot of cirrus up there, and there are the conditions for exhaust trails, plane trails, whatever you want to call them. So then now we can get back to the seeding part. And
shout out, Jim.
Was there seeding happening on that first period on the 7th, first, and then on the second period of the weekend following? Mm-hmm. So I have right here, is this at the right time? 7th at 0600. I got to back up because the time was supposed to be right there. 6th around 2300. And I had this set in the right place and I forgot to set it back. I need to find those two aircraft. They're both, this is probably it right here. Yeah, that's one of them. Let me fast forward this a bit until it gets up near Newcastle. So I have this guy on the right is what I'm looking at, and you can see right there as I move the time forward manually, you can see all the loops that it's making.
What are we looking at? Sorry, you'll have to just show us. Oh, okay. Could we zoom in on that, please? Because it's a little bit difficult to see.
I can. Come in. Oh, I should have done it the other way. I didn't need to do that. I could have just used my.
That's better. Thank you.
I'm going to play that a little bit and speed it up a little bit, and then I'm going to go and show you another aircraft. Okay.
So what's this thing doing?
It's doing patterns. You can see it's clearly making some kind of a pattern.
Okay, now there could be a number of reasons for this, because I know that they do like like when they're graphing topography, etc. That's right. The sort of pattern that they will do, and I'm not trying to give them a free ride here. But what else? What other reasons could that pattern be formed for? Why else would that be happening? Do you think? Is there anything else? I mean, cloud seeding, obviously.
Yeah, mapping. I mean, is there major construction going on there? I don't know of what forest assessments maybe.
Okay.
That would be a possibility.
All I'm trying to establish here is that every time we see patterns like that, it doesn't necessarily mean that there's cloud seeding happening. There could be other things. So I'm just trying to bring all those things into the equation as well.
Correct. So what I need to look at too then is what altitude should that aircraft be at? So I got to go back to Ventusky again. First of all, I want to show there's another aircraft that came from the same place, which is Bankstown.
Bankstown, there. Yep, that's an airport.
And there's another aircraft that went up at the same time. And I'm trying to make this thing click on that. I hate that big hand.
The big hand of Jeff.
Okay, come on.
It's very godlike, isn't it?
I got it. I made it turn red. So this guy's doing the same thing. And you could see, if I drag it, expand it a little bit, that guy's doing an identical thing, came from the same identical airport at about the same time. So right here is where he came from, right next to Sydney. The other guy did the same thing. There's his track. And I'm clicked on the Cessna T310R right now, and I'm going to look to see where he was, and I'm going to look and see that it was at 18,000 feet. And this guy over here was at, got to get rid of this. Click on this guy now. This big cursor causes me problems that I can't.
Yeah, sorry about that. It's Just the lesser of two evils of us being able to see what you're doing. Doesn't matter whether you can't see.
I'm trying to make it red so I can click on it, and it's just too clunky. I usually use a small cursor, but anyway, that was 18,000 feet, okay? So that first plane. Now I'm going to go to Ventusky again and look at the temperature at 18,000 feet and see if that's appropriate for cloud seeding.
Okay, so this is the pieces of the puzzle, folks. This is what you've got to do if you see these sort of behaviors and on flight radar you get the plane, then you go and have a look at this and verify whether it's at the sweet spot for cloud speeding or not. Cloud seeding.
So the answer is we're talking Brisbane area. What's the name of that place? Newcastle was where the one of them was. Yes. Newcastle, Australia.
North of Newcastle.
Oh, shoot. I had it popped up right there. You can't see it on the map. So Newcastle, Castle, Australia. There it is. From that far away. So this is where we're looking. So on the 7th at 0Z, I got to back up in time just a little bit. Well, it's close enough to the same time. It's not going to change that much. 18,000 is it's minus 21. 14,000 is minus 11
degrees Celsius.
11 degrees Celsius. And up here, that hand hides the value, minus 9 up by Brisbane. Okay. So they're kind of close between Newcastle and the other place was called Tamworth, I think it was.
Tamworth. Yep.
Tamworth, right?
Country music.
So this whole area is similar in temperature. So you would want to see somewhere near 14,000 for a cloud seeder. Right. And this guy right here is at 13,950 currently. That's pretty close.
Yep.
And then the guy up there when he was in the middle of that, he was at 18,000. So that one was probably too high. Maybe it's doing mapping. Hard to say. This guy down below fits possible cloud seeding. But when you look at that atmosphere, like I was showing you earlier, when I look at Brisbane Airport on the previous, let's say I got to go back to the 7th, right? Here's the evening of the 6th. Right. That's the one that applies. You can see that these two lines are really close together up to right here. And that's 3,000 meters, 10,000 feet. So that aircraft would have been somewhere up here in this dry area above clouds, dropping something into the clouds, seeds, if you were doing that. You have a pretty good condition here for cloud seeding because of that depth of that moisture. And if you were to look at
he was at 18,000. Was he at 18,000, did you say?
The second one was at 13,500, 14, where it should have been. Let's look at the windy.
Okay.
I X out of it and then go back to the same thing, 6th at 2,300. There we go. That fits. So you had at minus 10 degrees, minus 5 to minus 10. What do you have up here? Super, super dry air. There's a dew point depression of 14 degrees right there at minus 7 at minus 10. He's not in cloud. Cannot be.
It's very dry.
It was too dry for doing this type of stuff. You had some possible clouds right here, 6 degree dew point depression, 5 degree right there. You had clouds forming, but going back to the radar at that time, this is the 6th at the proper time, 06Z. I got to go back a little bit earlier by 2 clicks. And that's 0Z when he would have been there. Here's Newcastle. Tamworth doesn't show up, I don't think. Coming back here, reloading. Newcastle's here where the guy was at 14,000 feet. Tamworth is here. There was no rain at all. No rain showing up. And even
this is on the 6th, right? Okay.
This is on the 6th at 7:00, which is the time they're up there. You have not rain in the sky. All the rain's offshore.
Yeah, no, there wasn't any rain back then at all. It was just the cloud seeders, the planes that were spotted.
Okay, so we covered that the trails were there on this date. We saw the trails on the satellite views. Further north.
So let's just recap here. So are we saying that the conditions were not ideal for those planes to be cloud seeding at that time?
That's correct.
Okay, so the conclusion is that those planes particularly and those contrails had nothing to do with the weather that came afterwards. Is that the conclusion?
They were pretty inefficient if they were doing that.
Okay, that leads me to another question. No, I was actually referring to whether those planes were connected with the dump that came a few days later, and which leads me to the question of if they cloud seed, how they sort of have to do it at the time, don't they? Like they can't just cloud seed 2 or 3 days before and then rain comes 2 or 3 days later, can they? Like it has to be closer together.
You have to hit the time just right. It's got to be in those clouds that are ascending in updrafts. You have to be there at exactly the right time. And I've watched these guys over in California. I've predicted when they're coming and the flight level because I know rain's coming. And I would go to Ventusky and get the altitude and be looking at that spot where I know they go, and they show up at the right time.
Right. Okay.
They're looking at the same data and satellite that I am, and they have a meteorologist on board. Yeah, it's a guarantee.
Yeah, absolutely.
It might not be a meteorologist, but they might know this stuff that you need to know right here, and it's something anybody can learn. So,
okay, well that's good. We've got a conclusion there that you can't cloud seed a few days before a storm. It has to be at the time and hit the sweet spot right at that time. Okay, thank you.
And you're talking silver iodide, which has weight, so it's going to drop out of the air. It's the ideal time is at the exact right time, which is at the leading edge of when something's coming in.
Yeah. Okay. So
the question now is, when you go out in time, you could see there's the tail end of that cold front. Let me zoom out again a little bit. That cold front went through. Everything's clear. You got high pressure, 1030 millibar hectopascals, millibars. High pressure built over the rest of the state. You got another front over here coming in. So in the future, you could see what's happening right here. And that means what that is the front continues to the east on the 8th. On the 8th, it's farther to the east past New Zealand. On the 9th, you have another weak front right here, but you could see the tail end of that cold front left a bunch of moisture up here. And on the 10th, you could see it's closer to the coast. And if I look at the satellite, you could see there's a batch of moisture up there. And on the 11th, now all of a sudden, you're looking at the wind speeds and directions right here. That's the satellite. Those black lines are the wind direction. And you could look at that wind direction at any level. And let's just pick somewhere dead center, like 10,000 feet up. Those winds are coming in from the west. And that water temperature, sea surface temperatures are in the 20s. Look at the legend to the right. Orange is 25. So you've got, if it weren't for that hand, I could read it. Maybe I can go faster than that. 23. I got to outpace it right there. 22, 23. So it's really warm water temperature compared to The sea temperature or the land temperatures here are considerably colder, 15. So you have warm, moist air coming in from the ocean. And as you go through the 12th and you go through the 13th, you could see those winds continue. And that's high pressure out there. It's counterclockwise spin. You have a high pressure system parked right there, and it's just funneling. It's pushing all of that moist air inland. And if you looked at the satellite, you would see that area, let me back up a little bit because right there I'm a little too far. Right there on the 12th and on the 13th, you could see that's slowly moving to the south. And on the 14th, which is today, it's moved off to the southeast and getting out of there. But for that period right there, you were in a situation which was, let me go back to the 10th again. Okay, so that's, I got to go 1 hour farther to get daylight. That was moving inland.
Yeah, Queensland have copped quite a lot of rain.
And then
pretty heavy.
If we looked at the data that goes with Brisbane, which is a perfect representation of what was up there, and you go back to the 7th, you can watch, we can just step our way through here. So they're topping out right there at 10,000 feet. Go to the next 12 hours later, same thing. Next 12 hours later, it goes a little bit deeper up to about, maybe 11,000. It got deeper. Next, pretty much the same. It actually dried out a little bit for a period right there on the 8th. Then the 9th, it got deeper again, almost up to 600 millibars. Then it dried out again. And, what do I got going on here? 11th, 12th, 13th. I'm getting mixed up as far as time frames. Okay, so on the 11th at 12Z, it's that. Then you have more moisture getting way deeper up to 10,000 meters. This is on the 12th. Same thing right here. A lot of moisture with a couple little dry areas. And then here you have just thick clouds from top to bottom on the 13th, which would have been 10 hours earlier. What's the 12th for you, I guess, right?
Yep. No, 14th.
Okay, 1300. Let me go to that on the on Ventusky.
1300 on UTC.
1300. I want to go to that right now,
10.
which is 12.
That would be about 10 a.m.
12:15 right there. 12:18, 12:21, 1300, and go to the radar. And you should see a whole bunch of rain up that way at that time.
Yeah. Mm-hmm.
And the satellite goes along with that. And the satellite here goes along with that. And the satellite here, is that the right time frame? 11th to the 14th. I think why this one is freezing up is because it's 3 days of data. I just can't handle all that with my not so great internet connection.
So, okay, so with my layman's view on all this, it stands to reason, I guess, if the cloud is coming in from the ocean area, from the east, warmer temperatures in the ocean, it sort of stands to reason, doesn't it, that there's going to be a lot of moisture in these clouds coming in to the west onto the land.
Yes, especially if you have, the water temperatures were 10 degrees, 7 degrees warmer than the land. Plus you have a fair amount of hills over there, right? On the coast.
Yeah.
I can go to Windy and see the topography by zooming in and knowing that sounding right here, which was Brisbane on the 13th at 0. No, this is Williamstown. I want to go to Brisbane right now and look a day earlier. This is today. You have a thick layer of moisture today. And if you go back to the 1300, that's 1223, that's close. Look at what the sounding track like that. It actually went towards the west, then it went south, and then it went to the east. But look at that moisture. Solid moisture up to 11,000 meters, 35,000 feet.
Okay, so that little white track, that is the path of the radiosonde balloon, the weather balloon. Is that right?
That's correct. Yep.
Okay.
And the lifting condensation level, all you had to do is lift that air 143 meters to get it to condense into a cloud. And the convective condensation level, 326 meters. You needed 20 degrees. It was close to that when that sounding was released. It was 18. So you had convection and lift happening and moist air coming in from the northwest. And that disregard what you see here for satellite, because again, that's current. But when you go back to Ventusky, that's what was happening at that time. A strong push around that high pressure center is all it was. And high pressure centers are associated with good weather, usually, unless you're pumping in a whole bunch of moist air and pushing it up land and adding heat to it during the day, in which case you get this. You get a lot of precip happening. So what's what at 5 p.m., what time is that? What
UTC?
time is 5 p.m. in the afternoon in UTC?
5 p.m. our time? My time?
Yeah.
You mean?
Yeah. Like 0400 maybe?
12 minutes.
I'm thinking 0400.
About 7, I think, because we're 10 hours ahead of UTC.
When does it get dark?
7 a.m. It gets dark around about the 5:30 p.m.
Okay, so let me look at let me go back to flight radar. That's one way to do it. I'm thinking it's going to be like 0400 UTC.
Yeah, the 7th of August.
Same thing every day. The sun should be 0400. It should be seen dark coming in from the right. 0500. I'm wrong. I'm just trying to prove what time it is getting dark.
Does that show the darkness, that map?
Yes.
Okay.
Let me just zoom out.
It should be starting to get dark around about there, 5:30. Just, starting.
Computer's kind of trying to catch up here. Where's the darkness? My whole point here was afternoon heating makes a difference.
We are surrounded by darkness.
There we go. It's coming in from the west, so it's after what I was thinking. It's like 6:30 UTC, 7:30, 8 UTC. It's starting to get dark.
Oh, well, obviously I didn't see darkness when I thought I saw darkness because the map says otherwise. No.
So it's that conversion thing. 0800 UTC is maximum heating of the day. That's what I was trying to get to right here. And right there is 0900 UTC. One click back is right there. So that's maximum heating. That's your convective condensation level. That's your convective clouds, at which point it's just lift after that when the sun goes down. And that continued for another day, if I'm not mistaken, before it finally moved south. There's the 13th, and on the 14th, I think everybody's clear of it. But that's tropical moisture coming in is what it was.
Even though we're in winter.
Even though you're in winter. That's this band of clouds right here, that's called the Intertropical Convergence Zone. Has a fancy name, ITCZ, and it's just where you have the easterlies. You can see here north of the equator, they're northeasterlies, and down here there's southeasterlies, and you have all that wind converging. It has nowhere to go but up because it can't go down. So it rises there, and that's a shower zone. Called the ITCZ, and you get stuff wandering down this way, like this batch is right here, off of, I don't know what that land is right there. My geography is not the best, but that stuff can get entrained in the flow and pushed into northeastern Australia.
Yeah, okay. That all makes sense. I wonder how, I'm not going to start this conversation, but I am just wondering how the whole equator, how the weather changes at the equator fits in with flat Earth. But that's another show and another podcast. Somebody else's, not this one.
I have actually gave that some thought. It's like, how would the circulation patterns of the world work with flat Earth? I cannot envision it, because what happens now is they come together right here from north and south, and then they go up to 40,000 feet, and then they head north and south, and they come back down around 30 degrees north and south, Tropic of Cancer, Tropic of Capricorn, and then they're back down at the surface again, and from 30 to 60, the 60s is where the polar jets are. 60 degrees north and south latitude, which is, quite a ways away from the equator.
Polar jet streams?
The polar jet streams. Like if you look at just the temperatures at 18,000 feet, and you look for minus 17 to minus 20, minus 17 to minus 20 degrees is right where that purple changes to blue. And if I look at wind speed, or rather, at wind speed and 30,000 feet, which will show the jet stream really well, that's over the Kamchatka Peninsula up into Russia. You would see right here, over here, United States, over the southeast, you can look at the temperatures alone and just tell where that jet is by locating that minus 17 to minus 20 zone based on the temperatures. The jet stream divides the hot and the cold, and that happens to be right where the purple turns to blue on the 18,000 foot temperatures.
Okay. So how many jet streams do we have? We've got polar jet streams, and then we've got like the jet stream along the equator. Is that right or not?
Yeah, you have the subtropical jet stream as well. So you have the polar, which is up here at that purple blue continuum. Yep. And then it goes northern hemisphere, comes around that low, like looking over Moscow area right there. There's a big low pressure center, counterclockwise spin. That jet stream goes like that, and then up and follows down around the south side of the lows and just goes all the way around the Earth like that. Southern hemisphere, it's the opposite. Same direction from west to east, but right over southern Australia is where you are right now, currently, or the 13th. There's the 14th.
We're actually in the 15th today.
Yeah. Now. You guys are. Yeah, you're 10, 17 hours ahead of me on our time here, and I'm there in California. So as you go 7 hours that way, you're in London, and another 10 more hours to get to you.
So the jet streams are created because of the clash of the different temperatures, like the radical clash. Yep.
Yes.
Interesting.
So I think the goal for today was what? Did we get our goals?
Well, let's conclude what happened with Australia. We've seen. Oh, there was another question I had actually. Can we go back to the flight radar where you're showing the potential cloud seeder criminal suspect, I should say.
Okay, so I am. Where is that tab?
Thrown you
Australia,
out.
right there, right radar. Place. Okay, so on the 7th.
You had the actual plane information. What I'm trying to get to here is how we discussed earlier off camera. There was no availability of information for the plane.
Yes, good point. So
You had it.
Flight.
There is a tab where you've got it open somewhere. I think it's over to the left.
Okay, I want to go back in right here. I didn't show you how to do this. I had these all set up, but if you have the advanced version, you can get the playback. So that's my button right there. So the date was the 6th at 2300 when he took off. Okay, that's pretty close. Start playback on the 6th at 2345 is what I have that set for right there. And then I'll zoom back in on that area and find those two guys. There's Tamworth. I had that marked. Oh, I had it marked. Okay, I think that's Tamworth right there. And it's a NA. So this is the guy going to Tamworth.
That's what we want.
And if you go
Cessna.
to, NA is what it has. So it came from Bankworth and it went back to Banktown. Bankstown. And it's a couple hours later. We can just confirm that right now, even though they show the destination and the takeoff points, not available.
Yes. Now I want to ask about this. Why would there not be information available when information is available for pretty much every aircraft?
That's a very good question. I do not know that answer. Surmisables.
Inconclusive. Okay.
But you can see those two aircraft right there and one watch. Here at 0100 UTC, they're still both doing their thing. Took off from the same place.
Can we possibly zoom in on that a little bit more?
We can.
Buggering everything up. Excellent.
Okay. So 0120, I want to see them going back to where they're going. And then I'll show you how to check to see if they're there. Oh, shoot. I just lost both of them. They might be landed already. I want to click on this guy right here.
Is there any way we can get those? I'd like to zoom in a little bit closer if we possibly can, because it's very hard to see.
We can. Here.
That's
here
better.
we go.
Thank you. That's so much better. Thank you.
Okay. So you could see, first of all, again, there's this altitude speed graph, and you can blow that up, and you can drag it off to the side. I don't know why it says blocked right there. I'm trying to drag it, and it's not complying. Okay, there we go. So you can see at this point, he rose quickly, speeds increasing, got up to at 125 knots at 13,875, and he continued that for a couple hours, it looks like. And then what I want to see is where he lands. So I'm going to speed this forward. I'll get rid of that altitude graph. Speed this up a little bit. He's still making loops. I can go 30 minutes at a time right here. Okay, so there he's going. He's going there. He's going there. And looks like he's going back to the same place. No? Maybe? Down.
Yeah, it bothers me that there's no information, because there's no way of knowing how or who to contact, really, is there? If you want to find out more information.
Well, let's look at the airport now. So if I click on that airport, and that hand instead of a pointer. So here's the airport information, and I have to go off playback. I'm gonna click on the airport again. Okay, let's see. Bankstown Airport.
Bankstown. Yep.
And I could see aircraft on the ground. And the two that came from there were Cessna T310s and Cessna 210N.
Mm-hmm.
Pretty similar. So yes. I'm looking here. I could scroll down, and this starts with the ones that landed the most recently.
And they're about the same size as the King Air vehicles too,
yes.
I think.
Yes.
Similar.
So I'm looking for Cessna 210 or 310. There's a beach. That's the one that is used here in the States mostly. I'm looking for a 210 or a 310 Cessna. And you can see this is 40 hours ago. This guy landed right here, and it's going back farther in time. And when I did this search, I did not find them.
Uh-huh.
And they
Well, you've
landed
done
on
this.
the 7th or 8th. And if I could get a tail number, then you can track them. You can get
Yes, this is something
notifications.
else. This is something else that gets under my skin. There's no, oh, look, there's no tail number. So is that's sort of like a car driving without a license plate. Is that right?
That's what I see. Yeah, I don't understand how anybody can do that. So you can get into the aircraft info and the playback. So if I go to the aircraft info now, I can see that aircraft's flights history for a year with the gold membership. And this would have been the 6th, 7th that it was flying. That does not look like the one that we saw in the opening videos, the King Airs. So this guy flew on the 12th and on the 2nd. It didn't fly on the 6th or 7th. This is not that guy. It's the same type, but this is not it.
Well, it's good to be able to show that you can, this is the process of elimination as well. So it's just as much part of the methodology we need to know.
And if I look at some of its flights, I'm going to be looking for loops. And that's not a loop. Go back to the next one. This looks like a commuter.
Yep, certainly does.
It's just straight flights. Here's
Innocent.
Let's look for a 3-hour flight. They don't even have any. They have the flight durations right here. Here's a 2-hour flight.
Little short treks.
Yep, they're all just commuter flights. So this aircraft was not the one in question. All
right, we can let him go.
Yeah.
Free to go.
So there were no others. So I don't know where those two came from. They don't have identifying tail numbers. Therefore, I can't find out where they flew.
So how would one go about trying to find out? Is there any way apart from being there at the time? And
you would have to see them.
Yeah.
You would have to see them land. You would have to know they're landing, be close by, and be tracking them on flight radar. You know where they came from. If somebody's in Bankstown, you could tell them when.
You'd have to be there and crash tackle the pilot as he leaves the aircraft, basically, wouldn't you? Sort of.
They have a tail number. Every aircraft has a tail number painted on it.
Yeah, should have. Yeah.
They do, but for some reason, these two, it's just so coincidental that they didn't have. I mean, let's look at this guy right here. Here you can see AM 250, where he was coming from. Click on it again. This guy's going from Sydney to Armadale, Beach King Air 350. And I'll look at recent flights. And I can click on any of those. I go to aircraft info and then you see the whole list of all their flights.
Yep, like we did with the other one. Interesting. It's a lot of info there, but when there's not a lot of info, that's when the alarm bells should be ringing, really. More so.
Yeah. Why is that one
hiding?
Why are they not? They're not following the rules.
Yeah. They are not complying.
Just for the fun of it, the aircraft that I showed at the very beginning, where I learned a whole bunch of this stuff about it, was that aircraft. And that was 522 JP. I've had previous searches for that one because I used to follow it. So before it left California, that's a King Air right there. Before it left California, it was flying out of Modesto. And right now, it's, Korea. Incheon, that looks like Korea. That is Korea. So they're capable aircraft. They get around and they can send them anywhere. They were up in Fargo. They've been at Iceland. You name it, they can go there. They were in Fargo for a while, but this is the last flight that it did before it left California, right here. And you can see that's what it looks like. And if you look at that Ventusky temperature, you know where they're supposed to be to get that -5 or -10. And you can look at any point in the flight and see when he's there, he's at 13,200 feet and doing 199 knots. And around the curves, he probably slows down a little bit, 169 on the curves. And he just did loop after loop after loop after loop and landed in Modesto. So these are the most capable, in my opinion, from what I've seen, for cloud seeders, the King Airs.
Yeah. Mm-hmm. And the Cessnas, maybe.
Cessnas are, yeah, maybe as good. I'm not sure if they're, I haven't really looked elsewhere till this particular task.
I wonder what the chances are of a member of the public, like me, ringing up, say, Bankstown Airport and saying, can you give me some information about these planes that took off at such and such a time on this date? Do you think that they would give out that info, or what would I be met with?
Good question. Probably not. I would think not. I don't think they would tell you. You just got to go see it yourself. You have to know that it's, you don't know that it's there. That's a problem. You have to catch it in flight, and you don't know where it's going to be flying.
But we know it was there because it was on the flight radar.
Yes. So it might be there again, but you don't know what's the configuration of that airport. When you click on, here's the interesting thing. When you go to those airports, let me just show you, well, let's just try this one right here. Let's look at Richmond RAAF. That's not going to show you what aircraft are there. Let's go to a public one like Camden. You can see all kinds of stuff about that airport when you go to more. You got the arrivals and departures, they were there. And then you can get like the weather observations and on-ground routes, weather, statistics. Here's the airport statistics. Sometimes the place that I got jet fuel once when I tested the jet fuel was they had a camera. So I was able to see where the pumps were to where I could scope out the place. And this shows statistics and the weather and the routes and reviews.
So this is
general
information about the actual airport itself.
Yes, anytime you just click on that, you get all this good stuff about the airport. Reviews, webcam, here we go. Sometimes they have webcams, so you can maybe even see the aircraft by the webcam if you're really lucky, if they happen to be, maybe, I don't know. This one doesn't look like it shows that.
That's actually, let me make notes. So it's possible if we were able to get onto the Bankstown camera, if there is.
Let me go back to that one. Let me go back to that. I'll back up to it.
We might be able to find
Bankstown.
The little scoundrel taking off. Or coming back. Landing is the technical term.
Yeah, I am in general.
Is this Bankstown Airport? Oh, yeah,
this is. Okay. Yes, webcam.
Ooh, I wonder how much history they'll allow us to have.
So if you want to look at that, they usually sweep back and forth. They don't just look at one aircraft, at least in the airport that I got the jet fuel.
So they don't have like a camera for each runway?
No, not for... It just
not for
goes
us anyway.
Back and forth over the tarmac area. Yeah, it's not doing anything.
A general sweep.
Webcam.
Okay, get the camera off runway 1, all right?
Oh, here we go.
Just
live.
for the next 15 minutes.
You do have it now. So you should get a sweep. It should go back and forth, and you might see the aircraft if you can recognize what it looks like. I'm not sure.
All right. Well,
the airport that I got that compatible with your browser.
Oh, and all these annoying things.
I don't want to do that. I don't want to do
that. Now. Don't bother me, kid.
So you might be able to find it via that method.
All right.
With some difficulty. Tail number missing is a problem.
Yes. major problem. And I want to find out why that would be the case, if somebody is able to tell me. Tail, so what do you call it? Registration number?
Yeah, tail number.
Okay. Registration. Why would
Your
this be
rules
missing?
should be similar
Mister?
there, right? They should be similar.
I would hope so. It'd probably be, we'd get overseas pilots not knowing what they were doing, driving on the wrong side of the sky. Okay, we've got a little bit of detective work to do here. Why would this be the case?
I'll show you this. Here's the one I know for a fact. Has a good camera. This is what it looks like. Show it on the map. Zoom over to the United States, warp speed. And here you go, Modesto. Looks like I have to hit the more in this case. Webcam, where are you?
I wonder if the ADSB app might
Modesto live
have
map.
different info.
Oh, it's showing the flights right now. It's not. They may not
okay.
have the
That's
weather or the yeah. That's kind of a moot point. You might get a camera, you might not.
Well, let's get a wrap up of the situation in Australia. Would you like to give us a bit of a rundown of what your conclusions are to the question that was asked?
There was not cloud seeding. There was unlikely to be cloud seeding in that upper area of moisture because you had so much rain. They'd be in deep doo-doo if they were. Why would you be doing that and adding to, what did you say, 150 millimeters?
Over a couple of days, yes.
That's a lot.
100 overnight.
6 inches of rain. They should not be out cloud seeding.
And if anybody goes to check and says she's wrong, it wasn't 100, it was 88. I'm in a very slightly different suburb to where the actual weather things are red. So it does make a difference. I'm up at much higher altitude. So there is a little bit of difference. And also the time of the reading would make a difference as well. Because we personally read our own rain gauge at about 9 o'clock in the morning, which my mother religiously has kept for years, and charts and things. Whereas the Lismore Airport, I don't know what time they do their reading or how they do it, whether it's automatic or whether it's a little dude running out and going, oh, and then writing it down. I'm not sure. That's what they do. They go out and go, oh, 88. I'll write that down. Yeah. So that's what they say, 88, but we say 100.5 where we are, which is about, I don't know, 5-10 kilometres away.
And you were on the south end of that precept as well. It was heavier up north, so it makes sense.
Right.
So
anyway, so the conclusion is that dump was a natural rainstorm, and well, not related to cloud seeding, let's say.
Correct. It was just
by aeroplanes
due to the high pressure center located offshore, pushing moist air in for days at a time. And lifting up the mountains it was only a couple hundred meters was enough. And then by convection, you had warm enough temperatures during the afternoons to enhance that. Okay.
And that the contrails, chemtrails, whatever you would like to call them, the plane farts, it's much more neutral. Thank you, Jim Lee. They were visible because of the conditions, because the conditions were correct for the trails that are always there to be visible.
Correct.
Right. Well, that's our conclusion. I think
that's
we're done.
That's our conclusion.
Brilliant. All right. Well, we really hope that it's been really good to be able to show people how to do it and how much information is actually available. Now, if somebody sees something a little bit sus and they've got their flight radar and they've found out what plane it is, and then they want to go and find Ventusky or anything windy to find the conditions, which all the links will be down below. What information do they need? What do you need when somebody comes to you and says, Jeff, were they cloud seeding or not? What are the questions you ask them?
Oh, is rain coming? If it's not, they're not likely to even go up. Was there rain? Yes. than they might have been up. What was the altitude that they were at? Because that -5 to 10 matters for silver iodide. That's the sweet spot. And
okay,
were
but
they up?
even before that, the more basic, what you need is the location and the time.
Yes.
Yeah.
Location, time, and is rain coming? That's your first points of what you look at. When you look at live windy, to get your live temperature, pick a spot on windy. I mean, you could go anywhere right now, and say Denver Airport, Denver, Colorado International Airport, and in 3 seconds, you click on the icon, the circle for whatever the closest radius on is, and that's Grand Junction, Colorado. They're not very close together. And you could say this guy right here, -10 is right there. You have moisture here. It will be possible to cloud seed right here, right now, borderline, because you have a deep layer of moisture.
Yep. All right. So you need the time and the location, and preferably the flight radar, the information of the plane. That would be like a luxury, wouldn't it? But time and location primarily.
And rain nearby, because here there is. You just have to fly a little ways north to get to it. Yep. And the cloud seeder would be operating somewhere near one of those cells, trying to wring a little bit more out of it.
Yep. So just to be clear, if there was no clouds and it was all clear, there's pointless sending a cloud seeder up. It's just a complete waste of money, time, and everything.
Yes.
You should just go and do your knitting.
Except for them. 4 flights.
Except for these guys. Yep. They can always fudge the numbers because, statistics.
Yep.
All right. Well, I think we've pretty much cleared all that up, like a nice blue sky. And appreciate you showing us all that stuff, because it's pretty important to know how to do these things. People to do it themselves, because, there's only one Jeff. There's a number of people who could help, I'm sure, but it's not a short process, is it? It's hours and hours of looking and researching and figuring things out.
It could take you 15 minutes to figure out, okay, you already heard on the forecast, rain's coming, so you know it's possible. Then you know the airport that you don't know. You have to go up and actually just watch the skies on flight radar and set the filters on Ventusky and on flight radar to monitor that range of a couple thousand feet above or below that chosen flight level of -5 to -10. And you just have to watch and look for somebody doing circles.
Yeah. Okay. So but if somebody sees the trails in the sky, they just go straight to flight radar and see if they can find the plane that may have been responsible.
Right.
Because you should be able to find it if you've got your time.
You're talking contrails now, though, right? That's what you're saying right now.
Yeah, well, that's what most people sort of want to know, I think, is, when they see the trails, they want to know, well, are they cloud seeding? Or is this, you can figure it out, because if you find that it's the atmosphere and the altitude that is going to leave a contrail, then it's basically they're just leaving a contrail, because you can see it. They're always there.
I just switched over to the United States. Yeah. Oh,
I took you off.
You don't see?
I am seeing you now.
Okay.
Well, your screen anyway.
I just went to the main one that you go to, which is upper level tropospheric water vapor, and I'm waiting for it to refresh. And I can see that there's a whole bunch of clouds near -40, and I would be looking at the edge of this cloud shield, because where the whites are, that's the altitude where it's white, -40, and then you go to split window difference grayscale and start looking for lines in the sky. It's not showing any clouds. Yeah, they're there, but no contrails. And the reason why would be because if I went to Portland and I look up there and at 30,000 feet, 10,000 meters, it's a 15-degree dew point depression, there's not a chance.
No, it's not right.
However, up there, Quileute, Washington, it's closer, but it's still 7 degrees. You could pick another spot like Great Falls, and you do have less than a 5-degree dew point depression right there at 9,200 meters, 300 millibars. That'd be a real low flying jet, but possible. Anyway, that's all it takes.
Mm-hmm. Yep.
Check to see that you have the closer to zero, the better. The thicker the zone, the better for likelihood of seeing a contrail.
Yep, if those lines are a long way apart, then there's not a chance they're going to be cloud seeding. Too dry. At certain altitudes.
Yeah. If you were in this mess right here, like in Wyoming, or let's see, Rapid City, the clouds can be too thick. The clouds could be way too thick.
Yep.
So the problem here is you have the clouds here start at 8,000 meters and they go up to 12,000 meters. You have 4,000 meters of clouds. The contrail is just going to be eaten by the cloud. You'll never see it from below or above.
Yeah, for sure. Yes, but they are always there.
The poison is, yes, the
unfortunately,
metals.
that is the problem. Yeah, it's the fuel. But that's a whole other story. And if you'd like to know a little bit more, or a lot more, actually, about all that stuff, I'm just going to unshare your screen. Are we done now, Jeff?
Okay.
Yes, if you'd like to know a ton more about all these kind of things and the jet fuels and lots of things, go to climateviewer.com, where Jim Lee has the most brilliant array of information, which is constantly being modified and updated and added to. And he's got a heck of a lot about the historical information of this stuff that goes back a lot further than most folks realise. Yeah, anyway, climateviewer.com is the place to go for the real stuff without the hype and the fear-mongering. Enough said. Thank you very much, Jeff, for all this. It's been great.
Very welcome, and thank you. It's been fun.
All right. Well, thanks for joining us again, viewers, and any questions, anything like that, please don't hesitate to leave in the comments or join a Telegram, the Climate Viewer Telegram group, where we're both in there. Jeff and I are both in there, and many questions get asked in that feed, and we're happy to oblige. Thank you very much, and all the best to everyone. See you next time.